The pasture is quiet until it isn't. A gate clanks, a crow barks, wind presses the grass flat, and the herd reacts like wah kicked in a bucket. Bodies pivot, hooves scratch, air splinters with movement. All except one. The smallest freezes mid-stride. Legs go rigid. The body tilts as if a sculptor swapped meat for marble. It topples without a bleat, eyes open, breathing steady. A statue tipped into clover. The disturbance passes. The rigid form loosens, a blink, a shake, and the grazer rises unfazed. The ground keeps its imprint for a moment, then wind lifts it away. What just happened feels like a mistake pretending to be a plan. A vulnerability so precise it almost reads as strategy. In a field where running is law, one animal survives by becoming still, stone for a few heartbeats, then walking on as if nothing occurred. The logic is untraceable. The effect is unforgettable. The animal has many names, most of them rumors turned official. Wooden leg, stiff leg, scare goat. Myotonic goat is the plain, accurate one. Fainting goat is the famous one, and famously wrong. There is no faint. Consciousness never leaves. What looks like collapse is muscle refusing to relax, a startle response extended into seconds. This trait, myotonia congenita, defines an American land race that took shape in Tennessee more than a century ago and now grazes pastures across the South and beyond. In an age of viral video loops, fainting goat behavior is comic and strange. In a biology lab, it is a window into the cell's wiring. The cause is a mutation in a skeletal muscle chloride channel, CLCN1. A protein that normally steadies the electrical storms that start and stop contraction. Alter the channel and the membrane becomes excitable when it should be calm. The muscle locks when it ought to let go. The result looks like a fall, but feels, so far as veterinary science can tell, more like a cramp that resolves quickly, leaving no lasting harm. The breed persists because people kept it, bred it, and learned to value it. Heavy muscling for meat, calm temperament, a body that recovers in moments and goes back to grazing. This is myotonia congenita in goats, mundane on a farm lane, and profound under a microscope. Inside the body, the story runs at nerve speed. Startle arrives, sound, sight, touch, and the spinal circuits that ready a mammal for flight and fight ignite. In most muscles, the burst is brief. In this one, the off switch is flawed. With chloride conductance reduced, each action potential leaves behind extra potassium and a membrane perched too close to threshold. The next impulse arrives sooner, and the next. Fibers fire repetitively when asked for a single twitch. Electromyography translates the consequence into sound. A rising and falling whine that clinicians nickname the dive bomber, a signature of myotonia as unmistakable as thunder for lightning. In kids, the first episodes appear weeks after birth and never truly vanish, though many animals learn to brace, spread their stance, or ride out the moment and remain standing. Sometimes the stiffness is mild. Sometimes the limbs go plank straight and the animal topples, then seconds later stands. The neurology is clean, the physiology consistent, the phenotype repeatable, and yet the trait persists. How can a genetic condition that freezes muscles survive breeding, markets, and predators? Why didn't time erase it? The paradox begins with inheritance and consequence. In this breed, the mutation behaves mainly as an autosomal dominant trait with incomplete penetrance. One altered copy can be enough to stiffen a startle, but expression varies. The gene is old enough to have its own literature. A single nucleotide change, replacing a conserved alanine with proline, was the first molecular culprit mapped. Later work refined the catalogue and the testing that now names carriers and confirms the diagnosis. None of this is abstract on a hillside. The episodes are brief, they do not involve loss of consciousness, and, if the pasture is flat and forgiving, they do not exact a heavy toll. In a forested cliff country, this mutation would likely vanish. In a fenced field, it stayed. That is one lever holding the door open. The costs are real, but often small. Another lever is human preference. Myotonia comes with conspicuous muscle hypertrophy, deep chest, heavy rump, and carcass studies from land-grant programs have reported higher meat-to-bone ratios than typical meat goats, with crossbreeding trials showing yield bumps when myotonic sires are used. Over decades, breeders also selected temperament, quiet, manageable animals that browse and kid well and are easier to keep inside a fence. Add novelty and story, and the trait that startles the internet became a lineage that fills a niche. Still, a question echoes across the fence. Is there any sense in treating a fall as defense? The idea is seductive. In a herd sprinting from a threat, several bodies gallop and one locks up, tumbles, and becomes the visible target. If a predator stops to inspect the rigid outlier, the rest escape. Folklore has wrapped itself around that scene. The biology resists it. Field evidence for a genuine myotonic goat defense is thin, and scientists still debate whether any anti-predator benefit exists outside storytelling. What does exist is the broader animal startle response. Fast, stereotyped, and in most species useful, and a mutation that exaggerates one part of it. Here the reflex is not a plan. It is a door left open too long. Yet the herd outcome might occasionally mirror a strategy, even if no individual intends it. That ambiguity feeds the mystery. It also misleads. The animals do not faint, and they are not safer for freezing. In coyote country, stillness is a liability. In managed pastures, consequences are cushioned. In some barns, the physics of falling even becomes a point of husbandry, with clear runs and low hazards, so stiffness ends in grass, not injury. The trait persists not because nature favored it in the wild, but because people favored the animals that carried it. And because the episodes, while dramatic, are short enough to leave most days unremarkable. 3 possibilities try to solve the persistence puzzle without overpromising a single cause. The first is straightforward domestication. Historical accounts place the founding animals in Tennessee in the late 1800s. Few goats, many descendants. A small founder effect, then repeated human selection for meat conformation and docility could carry the allele forward with little opposition. Where husbandry is careful and landscapes are gentle, selection against the trait weakens. Where markets value heavy muscling, selection for it strengthens. In this reading, the condition is here because people wanted what came with it, a calm, well-muscled goat. Studies and breed descriptions reflect that logic. From meat-to-bone ratios near 4:1 to extension bulletins citing yield gains when myotonic bucks are crossed on other does. None of this makes the fall a defense. It makes the fall survivable and the body valuable on a farm. A second hypothesis is physiological trade-off. The same chloride channel that makes muscles lock under surprise also shapes how muscle fibers behave the other 99.9% of the day. In people with myotonia congenita, hypertrophy is common despite normal training. In goats, that hypertrophy is visible in the breed ring. If the long-term consequence of altered chloride conductance is a bias toward fiber recruitment that builds mass, then an allele that hurts a few seconds per week could help every hour of feeding and growth. That is not a proven mechanism. It is an inference pulled from the coupling of ion channel function, excitability, and muscle phenotype. But it frames why the body might spend more time gained than lost. The trait would then persist because its net effect under domestication is positive. Better carcasses, calm behavior, tolerable episodes. The price is paid in falls, the dividend is paid in pounds. A third possibility lives at the level of expression, not base pairs. The trait is variable. One goat topples at claps, another only stiffens at a dead run. And incomplete penetrance means some carriers rarely show the full event. In such a system, selection does not act against a constant. It acts against a scatter. If the most extreme animals are removed by chance or management, what remains are goats with a light touch of myotonia. The muscle and the temperament with fewer dramatic collapse. Over decades, that could drift the distribution toward animals that look like the breed but fall less often, especially in herds not rewarded for showy stiffness. This too is not confirmed, but it fits the observed variety within myotonic herds and the quiet fact that many episodes are mulled over in seconds and forgotten by noon. In that sense, the population's center of gravity sits where survival costs are low and human preferences high. All three ideas coexist with the cellular mechanism, which remains a model case of channelopathy. CLCN1 normally allows chloride to flow across the muscle membrane, damping the electrical echo that follows a burst of activity. Mutate the channel, and the echo becomes a shout. Action potentials arrive in volleys, and relaxation is delayed. On an EMG speaker, the trace sings that dive bomber song, pitch rising and falling as the firing rate waxes and wanes, turning invisible spikes into a sound that makes the physiology audible. It is the same physics from barn to biopsy. A membrane too easily excited, a fiber reluctant to let go, a limb briefly turned to stone until ions reset. Add surprise, add gravity, and the episode looks like a feint. It isn't. The animal remains present, eyes tracking, waiting for the switch to release. Then, as quickly as it began, the stiffness ends and the grazer walks on. That rhythm, lock, fall, rise, browse, rewrites what we thought we knew about how a mammal can fail to run and still survive. On a different day, the pasture holds its breath again. A dog barks from the lane, and the herd opens like a fan. The rigid one stiffens, sways, and settles. The dog loses interest. The wind moves the grass back into place. In a wild valley, the equation would end differently. The story here ends with sunlight and chewing. Can falling down be a survival strategy? In a literal chase, no. In a human landscape, sometimes yes, because survival is not only about outrunning teeth, it is about fitting a niche that people maintain. Fences that blunt consequences, pastures that favor calm bodies, markets that reward muscle, and caretakers who know that the episode is brief and the animal fine. The mammal that freezes into stone is not a riddle from evolution's edge. It is a lesson from domestication's center. A startle-locked membrane became a breed. An accident became a lineage. The statue rises, shakes, and vanishes into the ordinary business of eating. The mystery that remains is not why the body falls. It is why a trait this improbable keeps finding a way to live.